Now let's go back to Coulomb's law. We said F is equals to KQ1 Q2 divided by R squared. We want to know the effect of the quantity of charges when it's being increased on the electric force. Similarly, the effect of the charges when the difference of the distance between those two charges when it is being increased on the electric force. Now, what would happen to the quantity of electric force if the quantity of charges is increased? Since the electric force is proportional to the quantity of charges, so it means as the quantity of charges increases, then the electric force will also increases. Now, what about that of the distance between those two charges? If it is increased, what would happen to the electric force? Since the electric force is inversely related to the square of that distance, it means if the distance is increased by 2, then the electric force will decreases by a factor of 4. And if the distance is increased by 3, the electric force will decreases by a factor of 9. It will be keeps on being decreasing by a factor of the square of what the distance used to increase. So that's just what you need to know about the Coulomb's law as well. Now let's begin to go over some examples and see how this concept works. Number 1. A positive 10 microcoulombs point charge is 25 centimeters away from a negative 20 point charge. Calculate the magnitude of the electric force between them. So Q1 is indeed equals to plus 10 microcoulombs. Q2 is equals to negative 20 microcoulombs. And the distance between them R is given as 25 centimeters. So we have to find the electric force F. Now we need to convert the distance to meter. That's 25 divided by 100, and that is 0.25 meter. All the charges given to us are in microcoulombs. We need to convert them to coulombs. So that should be 10 times 1.0 times 10 to the power negative 6. And for the second one, that will be 20 times 1.0 times 10 to the power negative 6. So this will become 1.0 times 10 to the power negative 5 coulombs. And for the second charge, that will become 2.0 times 10 to the power of negative 5 coulombs. Now we have everything in the appropriate SI unit. We can now convert them, and we can now express them by substituting them into the Coulomb's law. So we know that the electric force is K, Q1, Q2 divided by R squared. I hope you didn't forget the value of K. Not in all cases it will be given to you in the problem. So the value of K is 9.0 times 10 to the power of 9 Newton meter squared per Coulomb squared. Now what we're going to do next is to substitute. So the value of F should be 9.0 times 10 to the power of 9, then multiply by Q1, which is 1.0 times 10 to the power negative 5, multiply by Q2, which is 2.0 times 10 to the power negative 5. Then everything divided by R squared, and R is 0.25 squared. So what I'm going to do next is to substitute everything to my calculator and have the final value of F once and for all. So I'm going to do that right now. So if you type everything properly, you should get 28.8 Newton as the value of the force. And that is the solution to the first problem. Number 2. By the way, feel free to pause the video and try to work this out. If you haven't subscribed to my channel, please do it to go and subscribe now. And don't forget to give this video a thumbs up. That will help me to go a long way. The second one is that the electric force of repulsion between two electrons of 1.6 times 10 to the power negative 19 coulombs charge each is 8.36 times 10 to the power negative 8 Newton. How far apart are the electrons from each other? So the force, electric force, is given to us as 8.36 times 10 to the power of negative 8 Newton. Similarly, the electrons Q1, Q2, they are both electrons, so therefore they carry the same charges. 1.6 times 10 to the power of negative 19 coulombs. Since this electron, negative sign will be there, even though it is irrelevant when substituting it in the Coulomb's law. Now we have to find the radius in meter. It's not given, so that's question mark. So I recommend you keep on doing this whenever you are dealing with any physics problem. That will help you to know where you are going and what to do. So what we're going to do is to substitute in Coulomb's law. We said F equals KQ1 Q2 multiplied by R squared. So our main goal is to make R the derivative formula. So I will cross multiply in the first place, and I should have R squared to be equals to KQ1 Q2 all divided by F. Since Q1 is equals to Q2, then I can have it as Q squared. Then I have R squared to be equals to KQ squared divided by F. Then finally, I should take the square root of both sides. Taking the square root of both sides, I should have the value of R to be equals to plus or minus the square root of KQ squared divided by F. And this is what I will work with. Now let's begin the substitution. So in order to do that, I need to get it in some things. I have to have enough space. So finally, the value of R will now be equals to the square root of 9.0, which is the value of K, times 10 to the power of 9, then multiply by the square of the charges, 1.6 times 10 to the power of negative 19 coulombs. So all squared, okay, all divided by the force, that's 8.36 times 10 to the power of negative 8. Then I'm going to do the same thing like I did earlier. I'm going to type everything into my calculator once and for all. So if you type it properly, you should have the radius of the distance to be equals to 52.5 times 10 to the power of negative 12 meter. And this will be your final answer. And that's it. Round 3. In the Bohr model of hydrogen atom, an electron Q1 is equals to negative E. Revolve around the proton Q2 is equals to E in an orbit of radius 5.3 times 10 to the power of negative 11 meter. The force of attraction between them furnishes the centripetal force needed to hold the electron in an orbit. Find the electric force. Find the electron speed if the mass of electron is 9.1 times 10 to the power of negative 31 kilogram. So let's fish out all these quantities given to us. So they said Q1 is an electron. And we know that the quantity of charge in an electron is 1.6 times 10 to the power of negative 19 coulombs. Q2 is a proton. And we know that quantity of charges in a proton is 1.6 times 10 to the power of negative 19 coulombs. So I've associated negative sign with that of electron. So we are given the radius in the exact SI unit to be meter, 5.3 times 10 to the power negative 11 meter. Then we have to find the force of attraction, which is the electric force, in the first place. So we are using Coulomb's law. So therefore, the force of attraction will be equals to 9.0 times 10 to the power of negative of 9, that's the value of K, then multiply by Q1. So since Q1 is equals to Q2, I can just have it as 1.6 times 10 to the power negative 19 all squared. Then all divided by R squared. So the value of R is 5.3 times 10 to the power negative 11 squared. So as we have been doing before, I'm going to type everything into my calculator and see the solution. So if you type that properly, you should get 8.2 times 10 to the power of negative 8 Newton as the value of your force. Now, according to the problem, the electric force furnishes the centripetal force needed to hold the electron in an orbit, which implies that the electric force of attraction is now equals to the centripetal force. And we know that from the definition of centripetal force, it is simply equals to mv squared over r. So therefore, the electric force is now equals to mv squared over r. With this, we can calculate the speed of the electron. So let's get into some things in order to have enough space. So if I should cross multiply, I should have the radius to be multiplied by the force of attraction and to be equals to the mass of the electron multiplied by the speed of the electron. Typically, it's squared. So I'm going to divide both sides by the mass of the electron and I have v squared to be equals to the electric force of attraction multiplied by the radius, which is the distance, then divided by the mass of the electron. Then finally, I should take the square root of both sides, and I should have the speed of the electron to be equals to plus or minus the radius multiplied by the force of attraction, or divided by m. So I'm going to substitute. The force of attraction, we got that to be 8.2 times 10 raised to the power of negative 8. So I will get rid of this in order to have enough space to substitute. So I should have the speed to be equals to the square root plus or minus. Then the 8.2 times 10 to the power of negative 8, then multiply by the distance between the electron and the proton. That's simply 5.3 times 10 to the power of negative 11, then all divided by the mass. And the mass is given to us as 9.1 times 10 to the power of negative 31 kilogram. So it's something you need to keep in mind as well. It's a constant value of the mass of an electron. In the case where you're not given, then she knows what to use. So I'm going to do the same thing by just typing everything into my calculator and see the final answer. So if you type that properly, you should have 2.2 times 10 to the power of 6 meter per second. And that is the answer to the second part of this problem. And that's it for this problem. Number 4. Two small spheres are 3 meters apart, center to center, in a large rate of water. They carry identical charges. C. Calculate the charge on each if each sphere experiences a force of 4 Newton. So we are given the force of attraction or repulsion, typically the electric force, to be 4 Newton. Then we are given the distance between them, R, to be 3 meters. So they said the quantity of charges of those two particles are the same. So C and C. So we have to find their the quantity of charges in each of them. Now you see that this one, they are situated in a large rate of water. And if you could recall, at the beginning of this video, I said the relative permittivity of water is 80. So therefore, in order to get the absolute permittivity of water, so what I'm going to do is that I'm going to solve for it. You notice that the formula for relative permittivity is that it is equal to absolute permittivity divided by the permittivity of free space. So if I cross multiply, I will have the absolute permittivity of water to be equal to relative permittivity of water, then multiply by the permittivity of free space. So relative permittivity of water is 80, multiplied by the absolute the permittivity of free space is 8.85 times 10 to the power of negative 12. So now what would that be? So that's 6.86 times 10 raised to the minus 10. So this is the absolute permittivity of water. So now I would like to get the value of K of the experiment. So to get that K, we know that's equals to 1 divided by 4 pi E naught. But in this case, it's no more E naught because it's not in a vacuum. It's now EA, which is the absolute permittivity of water. So that becomes, so K will now be equals to 1 divided by 4 pi, then multiply by 6.86 times 10 to the power of negative 10. So if you type that properly, you should get 1.16 times 10 to the power of 8. Don't forget, SI unit is Newton meter squared per Coulomb squared. So that is the value of K that we have to use. Now we can now begin the substitution. We have to solve for the quantity of charges. But don't forget, since the charges are similar, so the Coulomb's law can become KQ squared divided by R squared. Since the charges are similar, when they multiply each other, they become squared. So if I cross multiply, I should have the electric force to be multiplying the square of the distance between those two charges, then to be equals to KQ squared. My main goal is to solve for Q, so I'm going to divide both sides by K. Then I should have Q squared to be equals to F arg squared divided by K. And finally, to take the square root of both sides, then Q will be equals to plus or minus the square root of F arg squared or divided by K. So this is the expression I'm to use to solve for what I'm to solve for in this problem. So let me begin the substitution right away. So therefore, Q will now be equals to plus or minus the square root of F. F is 4. Then multiply by R squared. R squared, that's 3 squared, that's 9. Divided by the value of K. K is actually cancels that, but I can recall actually. So that's 1.16 times 10 to the power of 8. Okay, so I'm just going to type this into my calculator and see the answer. So if you type that properly, you should have the value of Q to be equals to 5.57 times 10 to the power of negative 4 coulombs. And that is the final solution to this problem as well. By now, you should have been familiar with how to deal with problems involving Coulomb's law. Let's try one more for this video. By the way, feel free to pause the video and check this one out. At least you can figure it out yourself as well. Okay, don't forget, if you haven't subscribed, please do go and subscribe to my channel. Thanks for watching. I really appreciate. So two charges Q1 is equals to 2 microcoulombs, and second charges Q2 is equals to positive 3 microcoulombs are situated in the medium such that they are 40 centimeters apart. Calculate the net force between the two charges given that the medium at which they are situated has a relative permittivity of 2.5. In this problem, they didn't specify the exact medium. We know in the previous problem we just did recently, they specify the medium, which is water. That's why we know that the relative permittivity of water is 80. That one is a fixed value. But in this case, they didn't specify the medium. Just let us know that the relative permittivity of the medium at which those particles are situated is 2.5. So we need not to bother. We just need to solve for the absolute permittivity of that medium. So first, we are given the relative permittivity to be 2.5. We are given Q1 to be negative 2 microcoulombs. Q2 is positive 3 microcoulombs. And the distance R is 40 centimeters. Almost everything given to us here are not in the appropriate SI unit. So to convert this, that's 2 times 10 to the power of negative 6. And to convert this, that's 3 times 10 to the power of negative 6. Coulombs. And what about 40 centimeters? That should be 4 points or 0.4 meter. Perfect. So let's come back to this relative permittivity. We know that the relative permittivity is equals to absolute permittivity or divided by permittivity of free space, E naught. Now, solving for E sub A, we know that E sub A will be indeed equals to relative permittivity multiplied by permittivity of free space. So that's indeed 2.5 times 10, perfect. 2.5 times 8.85 times 10. Okay, let me write that properly. I don't think this space will be enough. So permittivity of absolute will be equals to 2.5 times 10 raised to the negative 12 times 8.85. Okay, I have switched it. Okay, I'll switch it. So let me type that into my calculator. So that's 2.2 times 10 raised to the minus 11. If you type that properly, so that's the absolute permittivity. So the next is to get the value of k. Okay, so in order to get the value of k, that's indeed equals to 1 over 4 pi e sub a. So k will now be equals to 1 over 4 times pi times 2.2 times 10 to the power of negative 11. So that should be what? So let me type that into my calculator as well. So that's 3.6 times 10 raised to the power of 9. So that's the value of k. So that's the one we are going to use right now in order to solve for the electric force. So right now we can now use Coulomb's law. We have everything we need in order to use Coulomb's law. Perfect. So I'm just going to write k here. That's 3.6. So k is equal to 3.6 times 10 to the power of 9 Newton meter squared per Coulomb squared. So F is kq1, q2 divided by arc squared. So k is 3.6 times 10 to the power of 9. Then multiply by q1 is 2 times 10 to the power of negative 6. Then multiply by 3 times 10 to the power of negative 6. Then all divided by r, that's 0.4 all squared. So I'm going to type everything in my calculator and have my final answer in one time. So if you type that properly, you should have the electric force to be equals to 0.135 Newton. And that is the final answer to this problem. So by now, we should have been familiar with how to deal with any problem involving Coulomb's law. When they are situated in a vacuum compared to when they are situated in a medium, you should know how to get the value of your k respectively. Hopefully you find this content helpful. Thanks for watching. I really appreciate it. If you haven't subscribed, once again, please do well to go and subscribe to my channel. See you guys in the next video.